Hi, welcome to this lecture. We have been studying about various functions, and today what we will learn is function and its derivatives. So the question that we will try to answer or begin to answer in this lecture is the following: how do we use mathematics to study quantities that change in space and time? How do we use mathematics? So let's read it again. How do we use mathematics? How do we use mathematics to study quantities that change with space and time? In biology, we will often see, or not only in biology, in our day-to-day life, nothing is static. Things change in time very often, all the time. There's also all the curves that we saw are increasing or decreasing with x or y. So this increasing, decreasing with x and y, we can learn more about this and and any data that we get will be increasing and decreasing with x and y. So if we want to get more information from this data, if we want to learn more things from this data, we have to use some new idea called idea of derivatives. So there is a mathematical technique that one can use to extract more information and learn about something beyond the function, and that is what we would discuss, the idea of derivatives. So I will tell you what a derivative means, but before that let us recall the y is equal to mx graph that we learned. We had a simple graph y is equal to mx for different values of m. So let us try and plot that again. So when we had m is equal to 1, it was just y is equal to x, and then y is equal to x would look like this. So this is y is equal to x. If we had y is equal to 2x, we said it might look something like this. Y is equal to 3x looks like this. 4x and so on and so forth. So as I go larger and larger m value, so and half x. So if I draw like this, so this is y is equal to x as we said. So here this is m is equal to 1, and as we go below m less than 1, and as we go this way, m will be greater than 1. What is changing is this slope. So this curve has a slant or slope. So the thing that we change, m here represents slope. The more the slope, the larger the value of m. The lesser the slope, the lesser the value of m. So the first thing we want to say is that y is equal to 2x. So if I just think of y is equal to 2x and y is equal to 1x, this is 1x, then this is 2x. So 2x has more slope, this is more slanted. So this is y is equal to 2x, this is y is equal to x. This is more slanted, so this has a higher slope. So this has a higher slope compared to this. So this derivative, when we say derivative, is nothing but slope. So derivative is essentially slope, and calculating derivative is nothing but calculating slope. So I want to say that in mathematics there is a process called differentiation. So that is calculating derivative. If you want to calculating derivative, is same as calculating slope. So now this process in mathematics is called differentiation. So why do we do this? Because this is very useful. Calculating the slope is very useful. When we think of this two experimental data, think of two experimental data. So you do an experiment. Let us think of a simple experiment. Let's say in biological cells, there are molecular motors. Some motors called kinesin, dynein, and let us say they are walking along a track of microtubules. So some motor is walking. Or even think of we walking ourselves from one place along this line. So now if I do an experiment of we walking or a molecular motor walking, so molecular motor walk along some microtubule in cells, and let us say we are walking along a track or even a train going along a track. If you have a bus or a train going along a track. So these are different experiments that you can think of, different machines going along a track. Then you can ask a question, how much did it travel in time? Right? After 1 minute, how much did it travel? If they are going with so if we are doing these experiments, and here y is the position along this track. So this is y is equal to 0. This is y is equal to 1, 2, 3, 4, different positions as a function of time. This is moving along this track. And we will get some data. And if we plot this, we might get some two graphs. Let's say I did one experiment. So if I am walking, let's say I got this. If this is a car, I might get something like this. So this is time in the x-axis. So I did experiment of a person walking. So this is a person walking. And the position of the person in the y-axis as a function of time. And this is a car. So this is a car or a bicycle or a motorbike. So what is the difference between this and this? Here, after 1 minute, so let us say this is 1 minute. So time in minutes. So this is time in minutes. After 1 minute, if we look at it, how much distance the person travel? So if you consider this person, the red curve says that the person has reached only here. So after 1 minute of walking, let us say the person has covered 100 meters. So the person has covered 100 meters. The car or bicycle in the corresponding time would have covered many 100 meters. So this could be like 600 meters or so this is y is the distance in meters. So this tells that the red curve has a smaller slope that we know than the green curve. So this is a smaller slope, this is a larger slope. And this also tells that the red curve represents a slow moving object. There's a person, while the green curve represents a fast moving object. So if you now want to say that this is slow moving and a fast moving thing, we have to make use of this idea of derivative. So we will come here. So this is, if you have a molecular motor walking along a microtubule, you can write typical equation like y is equal to some vt plus c, where v is like the slope or m and t is like x. So it's like y is equal to mx plus c, where the x-axis is t and the y-axis is the distance the kinesin traveled, if you wish. And this is this equation V is velocity of the motor, C is the distance at time t equal to 0. So this is the graph that is plotted here. Now what is V? We all know that V is nothing but the velocity. And the claim here is that velocity is nothing but the slope. So as you know, velocity is equivalent of the m, which is the slope, and this has, the person has smaller velocity compared to a car. This we all know. So velocity is, how do we calculate velocity? Is change in distance by change in time. Now how do we represent that mathematically? So I can represent, if you have a yt graph, so this is t and this is y, I can write velocity change in distance by change in time, that is, if I change the time in, so at t equal to 0, so this is 0 and this is 1 minute. In 1 minute, how much did I travel? So the x, the time changed by 1 minute, how much did the y change? So this quantity, which we call this, so this is my y, this is my time, so this is delta y. How much did the y change when the time changed this much? So delta y by delta t, or this is velocity. If y is velocity here, this is delta v by delta, delta v by delta t is velocity. So this is velocity. How much did the, so this is position, of course y is position, sorry, this is not velocity, this is position, and the change in y with time is called the velocity. So delta y by delta t is velocity. So let us see this, the slope, how y changes with x. So if you have a small range of x, if I take, how much did the y change? So dy by dx is called the derivative of y. So finding derivative as a function, finding derivative of a function is nothing but calculating the slope of a function. So let us think about the slope a little bit more by taking the curve that we all knew. So this is the simple curve y is equal to x. So if I just take two values of x, so x is equal to 3, so this is my x and this is my y, so this is my y value. So if I just take x between 4 and 5, so the corresponding y value is also 4 and 5. So if I just take delta x is this difference, so that is 5 minus 4, and delta y is also 5 minus 4, this difference, and the slope m is delta y by delta x, or it's also, when delta x is very small, this can also be written as dy by dx. We will come to that, but for the moment let us consider these are equal things, same thing. Delta y by delta x and dy by dx is the same thing at the moment. We will discuss more about this later, but this is 5 minus 4 divided by 5 minus 4. So this is nothing but 5 minus 4 divided by 5 minus 4, which is 1 by 1, which is 1. So basically the slope of this curve is 1, which we knew y is equal to 1x is our thing. So m is 1. So m is nothing but delta y by delta x. So that's what I want to say here, that the slope. So now to calculate slope, let us a little bit understand this a little bit more carefully. So let us take this graph once more. So again, this is same curve, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the curve which is y is equal to x. Now I can take any two x values. So how do we calculate slope? Take any two x values you want. So let us say I want to take 2 and 6. So I took two x values. Any two x values you want, you take. The difference between this, so that is the delta x, the difference between these two x values, which is 6 minus 2, which is 4. Then draw a line touching the curve that you have and the corresponding, calculate the corresponding y value. And here also draw a line and calculate the corresponding y value. So the corresponding y value here is also 2 and 6. That's why this is y is equal to x. So delta y, the delta y is also 6 minus 2. This difference is 6 minus 2, which is also 4. So delta y by delta x is 4 by 4, which is 1. So this is how you calculate slope. So this is also slope is equal to 1, which we knew. So slope is, take any two x value, calculate this difference, which is your delta x. Calculating this y difference, this is your delta y. Delta y divided by delta x is your slope. So if you take two values of this, any two values you can take anywhere you want, and you will get a slope. So let us look at here. If you take 3 and 4, you will get 3 and 4. So 4 minus 3 divided by 4 minus 3, which is 1. If you take 7 and 8, you will get 7 and 8. So you will get, this is 8 minus 7, 8 minus 7, you will get the value which is 1 by 1. Now if we take a more complicated function, which is, let us say y is equal to 2x. So this is the function that we want to consider now, which is y is equal to 2x. So if you look at y is equal to 2x, you have, when x is 3, y is 6. When x is 4, y is 8. So if I just take dx as this and dy as this, 4 minus 3 is 1, 8 minus 6 is 2. So 2 divided by 1, so which is 2. So the slope is 2. So if you take 7 and 8, the 7 correspondingly 14, 8 would correspond to 16. So 16 minus 14 is 2, and this would mean 2 divided by 1, which is 2 again, which of course this also shows that is independent of x. So that means if you calculate the slope here or here, you will get the same value. And I want you to understand this a little bit more carefully. So let us think of a graph a little bit more carefully. So let us take this graph, and I am going to put some values here, which is slightly different from what is printed here. So consider this graph, which is a straight line. So now I am going to put some values here. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And here I am going to put values 2, 4, 6, 8, 10, 12, 14, 16, 18 and so on and so forth. Now this function, then this plot will become y is equal to 2x. Now as we just did, to calculate the derivative of this, you have to take any two values, 2 and 3. Find the difference between this x value, so that is delta x or dx, which is 3 minus 2, which is 1. Then find the corresponding y values. So the corresponding y value here is 4 and the corresponding y value here is 6. So delta y or dy is 6 minus 4. So this difference is 6 minus 4. So 6 minus 4 is 2. So then if we calculate delta y by delta x or dy by dx, so this is my dx, which is 1, dy, which is 2, dy by dx is 2 by 1, which is 2. So the derivative of this is 2, that's what we saw. Now if we were to take some other value of x and y, you will essentially get a similar number. If now you can think of doing the same thing, take 4 and 5, correspondingly you will get 8 and 10. So this is 1, this is 2, so you get 2 and this is 1, 2 divided by 1, you will get again the derivative is 2. So the point I want to make here is very simple, that to calculate the derivative, what you need to do is take any two x values and calculate delta x, take any two values and calculate delta y, and delta y by delta x is my slope. Now let us think of doing this for a curve. So before that, let us see that. So look at this video. So I am going to start with 3 and 4, and I have two curves here, which is y is equal to x and y is equal to 2x. This is y is equal to x and y is equal to 2x, and I am starting with 3 and 4. So my x1, so two x values are 3 and 4. So the delta x is 4 minus 3, which is 1. Then I draw a curve to this y is equal to 2x graph, and I look at the corresponding y values, which is 8 and 6. But if I look to the y is equal to x graph, those are 3 and 4. So here the difference is 4 minus 3, which is 1. Here the difference is 8 minus 2, which is 6, which is 2. So this has, even though delta x is 1, which is the same for both, the delta y for the y equal to x graph is different from the delta y for the y is equal to 2x graph. So therefore, the slope of this is different from the slope of this. So I want you to understand this, for which I will play again this once more. I take some two x values 3 and 4. The corresponding y values for the y is equal to 2x curve is 8 and 6. But for the same delta x, the corresponding y value for this y is equal to x curve is 3 and 4. And therefore, the delta x by delta y by delta x will be very different, and I want you to think about this. Now we want to quickly understand this for a curve. So instead of you go beyond a straight line, if you consider a curve, so think of a curve like this. So I have here 0, 5, 10, and this will be in between 2.5, I would think, and this is 7.5, and this is minus 5, minus 2.5, minus 10, 7.5, and the correspondingly, let me draw some important values here. So this is 0, of course, this is 10, 20, 30, 40, 50, 60, 70, 80, and so on and so forth. So if I want to calculate the derivative of this, I can calculate the derivatives at different points. So let us say I take this as my delta x, 2.5. So these 2 points as my delta x, and corresponding to this, I can get the corresponding y value here, and I can get the corresponding x value here. So for this, I can get the corresponding y value, which is here. So if I just take these two x value, which is my delta x, this is the corresponding y value, this is my delta y. So calculate this value and find this difference and divide. That would be the slope. So that is one way of calculating this, that's a way of calculating the slope. So let us do that. Look at here. So if you just take y is equal to x square curve, if I take 3 and 4 as my x values, the corresponding y values are 9 and 16. So I will get 7. On the other hand, if I take 7 and 8, where delta x, the change in x is 1, the corresponding y values will be 64 and 49, and this difference is very different from this difference. So wherever, if I calculate the slope here and if I calculate the slope here, it appears very different. On the other hand, in this earlier curve here, if I calculate the slope here or slope here, it's same. So in the straight line curve, slope is independent of x, but in this case, slope is dependent of x, and the slope for this is 2x, which we will come back and learn about it. But at the moment, it is enough to understand that different places you calculate slope, you will get different numbers, and we will come back and learn about this in detail. So to summarize what we just did so far, we talked about slope, which is m we call, which is delta y by delta x, change in y divided by change in x, which is also we call it dy by dx, and that is at the moment they are the same. And we calculate the slope for a straight line and some curve. We said that this is calculating slope is calculating derivative is same as calculating slope. Calculating slope is same as calculating derivative. So this is what we learned in this lecture. We learn about this finding derivatives more in detail in the coming lecture. For this moment, we'll stop. Bye.